Good afternoon. My name is Ravi Babu, Assistant Professor. Today we are going to see in second module, system response. In this module, already we see the system response with respect to the jet transform, in case of the inverse jet transform, and for discrete time systems. Now I am going to for the pulse transfer function for the jet transform. Now, first of all, what is the jet transform in case of the pulse transfer function? So here I am going to considering the linear time invariant system. That is, it is going to changing with respect to time linearly. I am taking the type of the system is linear time invariant system, and it is also a discrete time system. Okay, so I am representing here in the block diagram. That is LTI discrete time system, where as here input is the x of n, output is the y of n, and the characterized system response is the h of n. Okay, so the output is going to be y of n, and the input sequence is x of n, and the system characterization will be the response of the h of n. It is also will be a weighting sequence in discrete time impulse function. In case of the discrete time impulse function, where we know the impulse function is, that is, it is 1 for n equal to 0. It is not equal to 0, where it is not equal to 0, n not equal to 0, the impulse function is coming to as 0. So finally the transfer function of the system is y of n equal to, output of the system is y of n equal to x of n into system, that is h of n. Now I am going to finding the jet transform of this system is, for this one, y of n equal to x of n into h of n. For this one I am going to finding the jet transform. So it is coming to y of z and x of z into c. So h of z equal to y of z by x of z. That is nothing but it is called as h of z is called as a transfer function of the linear system. If the input signal is, if the system is impulse response system, then the x of z value, impulse response of the x of z value is 1. So the output y of z is coming to as the input, the function. So the transfer function is also defined as the jet transform of the impulse response of the system also. So jet transform of the impulse response system also. Now I am taking, so finally what I am concluding here, the transfer function is, it is also defined for the jet transform of the impulse function also. Now I am going to taking the impulse function. What do you mean by impulse function? Here I am taking the r of k is the input function, and output of this one is y of k, and the output of this one is, we are getting a convolution of r of k and g of k, where g of k is the system. So when I am going to for convolution, so I am taking for infinity levels. So g of k is function is going to, I am taking the interval of one negative interval, that is g of k minus 1. By convolution property, we have y of z equal to r of z into g of z. From that one, g of z equal to, the system response is nothing but the transfer function of the system is equal to y of z by r of z. And here we are going to considering the making the all initial conditions are 0. That is, in a system, the components is going to be analyzed with the finding of the transfer function is at the 0 initial conditions. If there is no 0 initial conditions, is nothing but they will be having the with the time interval of negative sequence of time interval and positive sequence of time interval values. That's why we are, for finding the transfer function, we are going to taking the all 0 initial conditions. Now here y of z is the r of z and z transform of y of k. So y of z and r of z is the z transform of y of k and r of k, where G of z is the z transform of impulse function. Impulse function. And this is G of z is also called as a pulse transfer function. So here I am going to defining the pulse transfer function. Pulse transfer function is nothing but it is defined as the ratio of z transform of output to the z transform of input, making the all initial conditions are 0. Making the all initial conditions are 0. That is, for the function is in the form of the time domain. Now I am going to convert that into z domain. After that one, I am going to finding the transfer function. That is, g of z equal to y of z by r of z, making the all initial conditions are 0. And its z transform pair with the impulse response. Impulse response. Now we will see some of the values according to Laplace transform and star Laplace transform in Z transform and Z transform also. Okay, so where x of t is the input function, and here we are going to be taking the pulse function, that is this one pulse function, that is as like a switch. So x star of t, that is nothing but x star of t equal to x star of kt, where x of kt equal to x of k. So taking the Laplace transform of this one, so x of s is coming to as x of s and limit is applied for 0 to infinity. So x of t into e power of minus t, x of t into e power of minus t. That is, here we are taking the function is x of t. When I am going to taking the function is x of t, it is coming to as x of t into e power of minus t into dt. After that one, I am going to start Laplace transform. Start Laplace transform is nothing but that integration is coming to as the 0 to infinity, okay, summation, and x of k of t equal to e power of minus kt. Remember, okay, it is, if it is Laplace transform, in case of the star Laplace transform, it is coming to x star of s, and that integration part is coming to derivative part, and x of the discrete time is coming here, k of t e power of minus k of t into dt. Okay, t, only summation, no, integration is cancelled to summation. Okay, next, coming for the z transform, for this one, x of z equal, for this one z transform, x of z equal to, okay, already we know this one, already previous in z transform formation you have seen that one, sigma k equals 0 to infinity, x of z into z power of minus k. Only new terms are this one and this one. Okay, it is also both. Only star Laplace transform is coming. Okay, take the sum of the important properties of star Laplace transform. That is, if x of s equal to, for this one, star Laplace is x star of s. Remember this one. X star of k equal to x star of only x. After that one, here we are having the two functions, that is x1, x2. If you are adding or addition, and we are going to get taking the start function, so it is coming to as x1 of star plus or minus x2 of star, whereas you know another property is I am taking the with respect to k, okay, power x1 of s into x2 of s equal to k. In this case, it is coming to as x1 of x2 star s, x1 of x2 star s. That is nothing but the second variable is coming to only for the star Laplace transform. Coming for the next one is two stars. One variable is star, and for total function I am taking the star. Okay, so that is, first of all I am taking the one variable with star and multiply with same that one variable with normal. Okay, normal way. So that is coming to x1 of s. So in this case, what happened? It is coming to as x1 of star into x1 plus it is coming to same as the x2 of this. Sorry, it is by mistake. It is coming to as here x2. So x2 of star, this one. Okay, these are the properties you have to learn for previous any problems coming. Okay, next. Now I am going to finding the pulse transfer function if two blocks are in series. Okay, So first case I am taking as the blocks are separated by a sampler. Okay, the blocks are separated by a sampler. This is the one of the sampler. This is the one of the sampler. Okay, this is pulse transfer function sampler. This is also pulse transfer function sampler. Where here in this one, R of S is the input. It is R star S. G of S is the forward path. Weight of W of S. W star of S. Okay, this is the output of this first transfer function, first block, and G2 of S, output Y of S. Okay, it is time signals T. Okay, for seeing the block diagram, what is the W of S? What is the W of S? This is W of S, no? W of S equal to G1 of S into R of S. G1 of S into R of S. Okay, G1 of S into R of S. Now, I am going to taking the, for this function, star Laplace transform. Star Laplace transform. So, what are you getting here? See, that is, it is coming to, see the previous properties. Which one? W of S equal G of S into R star of S, no? So, this multiplication, these two, do this one, last one. Okay, like this. So, what I meant, W is star Laplace nothing but W star of S equal to G1 of S into, okay, G1 of S into R star into whole power of K. It is coming to as K. Okay, it is coming to as K. So, the star Laplace is nothing but G1 of S into R star of S whole power of K. Whole power of K. So, this is equal to the G1 star of S into R1 of star of S. R1 of star of S. So, it is equal to this one. Coming for the next one, transfer function Y of S. Where is the Y of S? Y of S is there here. Y of S is there here. So, this Y of S equal to G2 of S into W star S. W star S. So, what is the G2 of S? G2 of S into, what is the W star S? W star S is nothing but this one. This one. Okay. This is W star S. Is that. So, substitute this one here. So, G2 of S into G1 star S into R of S. Now, I am going to taking the, again, Z transform. Z transform. So, Y of Z equal to what? Y of Z equal to G1, G2 into R of Z. Okay. G1, G2 into R of Z. From this one, what is the transfer function? Y of Z by R of Z equal to G1, G2. G1 and G2. Okay. So, it is in case of when two blocks are in cascade connection. Okay. In case of the pulse transfer function. Okay. Next. Case 2. Case 2. Coming for here. In case of the case 2, they are going to be separated by sampler only. Only one sampler. So, R of S, T, R star of S, G1, G2 of S. Where in previous section, two blocks are in series with two samplers. Two samplers. Okay. So, similarly go for here. Present section. So, what happened? Here, Y of S equal to R, when the switch is closed, R of S into G1 of S into G2 of S. G2 of S. Now, similarly, previous section, same. Taking the star Laplace transform. What happened? This Y star of S equal to R star of S into G1 of S into G2 of S into whole power of K. Similarly, see the previous. Same. Here, W of S equal to G1 of S into R1 of S into whole power of K. So, similarly, here also. R star of S equal to, R star of S, G1 of S, G2 of S, and whole power of K. Whole power of K. So, after this one, if it is whole power of K, nothing but from the basic properties, it is coming to as alpha of S into G1 of G2 of star of S. So, this total function, these two forward path is coming to as star function. In that one, G1 is press and G2 is the star function. So, S will be present. Okay. So now I am going to taking the, for this one again, Z transform. Z transform. So what happened? Y of Z equal to R of Z into G1 into G2 of Z. G1 into G2 of Z. From this one, Y of Z equal to R of Z by G1 into G1 into G2 of Z. G2 of Z. Okay. This is the way when the blocks are in separated by a sampler in cascade reaction. Separated by a sampler in cascade reaction. Okay. So you have to remember one more important point here. That is G1 of Z is not G2 of Z is not equal to G1 G2 of Z. G1 G2 of Z. Now I am going to move in the pulse transfer function of the closed loop function. Closed loop function. Coming for here. Now I am going to finding the pulse transfer function of closed loop function. Taking here R of S is the input function. Okay. E of S is the error function. And for this one, I am going to taking the pulse transfer function nothing but star Laplace transform, that is E star of S is coming. So G of S is the forward path, Y of S is the output, H of S is the feedback path. Okay, by taking the almost pulse transfer function, and B of S is the H of S of the value. H of S of the value. That is the feedback value. Now I am going to finding the closed loop function, pulse transfer function. Now, see, from this diagram, we have E of S equal to this E of S equal to R of S minus B of S. R of S minus B of S. Okay. For this one, I am going to taking the star Laplace transform. Star Laplace transform. When it is coming to star Laplace transform, E star of S equal to R star of S minus B star of S. Okay. After that one, I am going to applying the Z transform for this one. So E of Z equal to star is coming to Z. Okay, remember, first one is normal function. After that one, star Laplace. After that one, Z transform. This is the procedure up to now I am going to in this way. So E of Z equal to R of Z into minus B of Z. From this one, R of Z equal to E of Z plus B of Z. E of Z plus B of Z. It is taken as equation number 1. Equation number 1. Okay. Now, again from the diagram, see this diagram. So, E of S is completed. Now, I am going to Y of S. Where is Y of S? Y of S is there. Here, Y of S is there. For Y of S, how many blocks are coming for Y of S output function side? G of S into E star of S. G of S into E star of S. So, I am writing as here E star of S into G of S. Y of S equal to E star into G of S. Again, same process. We have to take again for this one Laplace transform. Star Laplace transform. So, it is coming to as Y star of S equal to E star of S into G star of S. Okay, star Laplace for this one. This one. After that one, taking the inverse Z transform. So, Y of Z equal to E of Z into G of Z. G of Z. So, I am taking this is a equation number 2. And coming for next one. So, here B of S. What is the B of S is? B of S is the thing, but this is B of S, no? B of S equal to E star of S into G star of star. Okay. So, this one. E star of S into E star of S into G star of S into S star of S. Okay. B of S equal to. See. B of S equal to E star of S into E star of S into G star of S into S star of S. Okay. So, up to this one value see E star of S, G star of S into S star of S into, after this one, taking the Laplace transform, we are getting as, star Laplace transform. So, we are getting as B star of S equal to E star of S into G star of, okay, S into S star of S. So, for this function, I am going to take the Z transform finally. So, this Z transform is coming to as B of Z, E of Z, G of Z and H of Z. Okay, that is equation number 3. From 1 and 3, that is, what is the first equation? R of Z equal to E of Z, R of Z equal to E of Z plus B of Z. Okay, R of Z equal to, first equation is R of Z equal to E of Z plus B of Z. B of Z. This is first equation, no? So taking the first and second equations. So here R of Z equal to E of Z plus, okay, what is the B of Z? B of Z is this one. E of Z into G of Z into H of Z. From this one, so we are getting as output Y of Z by R of Z equal to, from this one, okay, so it is coming to as E of Z into G of Z, this one, equation 2, okay, by E of Z into common is common, take it common, so it is coming to as 1 plus E of Z into H of Z, 1 plus E of Z into H of Z, okay. So this is the pulse transfer function of the closed loop function. What is that one? Similarly for same as control system. Okay, G of S by H of S, G of S by 1 plus G of S into H of S. Here G of Z by 1 plus G of Z into H of Z. Okay, so this is the pulse transfer function of the closed loop function. Same as, what is that answer? Final answer, G of S by 1 plus G of S into H of S. H of, sorry, in case of Z transform, H of Z. So this is your pulse transfer function for in case of the Z transform. In case of the Z transform, now it is completed. Tomorrow we see the another section. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.